Welcome back to another episode of Learning Derivatives. This lesson will be learning integration by parts using e to the power of x and Lagrange's notation. So, here is the formula for integration by parts. You start off with something you're looking to find the integral of, and this is what you gotta. This is what it spits out, and this is what you have to work out. And over here is what we will be. The sort of general rules you use for e to the power of x. You have when you have e to the power of x, and then when you find the integral of that, it's just e to the power of x plus c. And when you have e to the power of kx, k is a number. When you find the integral of that, you get e to the power of kx over k plus c. Okay. Now you know those. Let's do some examples. Here we have example 1. Function equals e multiplied by e to the power of x. Now we know we need to use by parts because we don't use substitution. And we don't use substitution because if we were to derive whatever's in the brackets up here, it wouldn't help us eliminate this, the first function. So that's why we don't use substitution. But it's still a function times a function, so we still use either substitution or parts to find the integral. Anyway, we've established that we use by parts to solve it. Some people like to write by parts, but I'm not going to because I've explained it and it's going to take up too much room for me. But now I'm going to find the integral of both sides. So the integral of the fx side turns the lowercase f into a capital F. And when you find the integral of this side, all we're going to do is put the integrand symbol and dx on either ends. Okay. Now if we have a look at this formula, they look very similar, and it's mainly because of the integrand and the dx. But in order to solve this, we need to start with this. So we can assume this is this, and that way we can solve this. Now I'll show you what that means. We need an fx, which is just the standard function, and we need a g dash of x, which is the derivative of a gx function. Okay. So one of these needs to be, and think about it this way. We need a derivative of fx, so the fx that we pick, one of these that we pick to be the fx, we have to derive, and we need to find gx. So the one that we pick, the one of these that we pick as g dash of x, we need to find the integral of. Okay, that might have confused you a bit, but essentially we need an fx, an f dash of x, a gx, and a g dash of x. These are what we need to solve this question. So we got to label one of these as fx and one of these as g dash of x. Let's say x. We'll call that fx. So, and we'll call e to the power of x g dash of x. Okay, so if we need to find the derivative of fx, and fx is x, then the derivative of x is 1. And if we need to find gx, and the derivative of gx is e to the power of x, then we need to find the integral in order to get this. Now the integral of e to the power of x is e to the power of x plus c. Although in this step I'm not going to put the plus c on because we'll be putting that on later. But I want to show why I did this. If you've watched my other videos and you know this, then by all means you skip it or go past this bit, but I'm going to explain it. And it's basically, I pick x to be my fx because I know I have to derive it. I don't want to have to derive e to the power of x because that would just become e to the power of x. So I chose x to be the fx because if I derive it, I would get 1. And you want something, the one you want to be fx out of these two is the one that simplifies when it derives. You don't want more mess, you want less mess. Okay? So, we start off with x e to the power of x dx equals. Now, if I rearrange my papers, we can make that look similar. See? We made x fx and we made e to the x g dash of x. Now, if we're following this, if we're assuming this is this, then we can solve this. So fx we've established is x. Gx we've established as e to the power of x. And minus the integral f dash x we've established as 1. And gx we've established as e to the x. So we have 1 times e to the x, or just e to the x. Now the reason I did this, the reason that is also part of the reason why I made fx x, because I knew that I'd be multiplying f dash of x onto something. If I made f dash of x 1, then when I multiply 1 onto something, it gets rid of it. So it makes everything smaller and easier to deal with. So instead of having two functions I have to work with, I only have 1. Okay? So now we have that. We can solve. Here's the easy part. X to multiply by e to the power of x stays the same. Subtract the integral of e to the power of x. Now, just like before, we've already said that the integral of e to the power of x is e to the power of x plus c. I didn't do it in this step because I don't think it counts in this step because we have I just don't like to do it in this step. I like to do it in this step because we have g dash of x and gx, and I don't want to deal with plus c's and whatnot up here. I want to deal with plus c's as I start answering the question itself. Okay, so we leave that the same, x multiplied by e to the power of x. Now we got to multiply the minus sign. We got to expand the brackets. So we got to multiply the negative onto the e to the x and the negative onto the c. So it'll look a bit like this. Okay. Now, I like positive numbers here. So I'm going to write a key that says h equals negative c. Just like how you have fx will equal this and g dash x will equal that, I'm saying h will equal negative c. That way, we can have x multiplied by e to the power of x minus e to the power of x plus h. Because I just like positive numbers. I like to have a positive constant. Anyway, we can factor out the e to the x, and it will look a bit like this. And now it's simplified because all we did was just take away the e to the x from the x and take away the e to the x from the negative 1. Because if we expand these brackets, it will look like this again. But this is simplified. Okay, so that is the answer to the integral of x multiplied by e to the power of x. Now for our next example, example 2. Okay. This is in this step I'm going to show you a question that'll come up where you have to do integration by parts twice in the same question. Okay. So we have fx and I'm going to make it equal to x squared multiplied by e to the power of x. Now this is different from the last question. Last question was x multiplied by e to the x. This is x squared multiplied by e to the x. Okay, so find the integral of both sides. Okay, and we decide which one's going to be fx and which one's going to be gx. If we were to derive this, it wouldn't simplify. If we were to derive this, it would simplify more than this. So we make this fx, and we make this g dash of x. Okay? So we label fx as x squared, and we label f dash of x 2x. And we have gx, and we have g dash of x. G dash of x is e to the power of x, and gx would then be e to the power of x. Okay. Now, we have the formula here. And we're going to need it for the next step, which is filling in. Okay, so we started with the integral of x squared multiplied by e to the x dx. Now we need fx, x squared. We also need gx, e to the power of x. Subtract the integral, f dash of x, 2x, gx, e to the power of x, dx. Now, here is where we come up to the part where we need, come close to the part where we need to find the second integration by parts. Okay, so we have x squared multiplied by e to the x minus, now here we have a 2 multiplied by an x multiplied by an e to the power of x. So multiplication by a constant, the 2. So that means we bring the 2 out the front. That way we find the integral of only the variables. Now, this looks similar, because it is similar. It's the question we just did, the previous example, x multiplied by e to the power of x. So, in order to solve this little part here, we have to find the integral again. Now, okay, so you'd have to find the integral again. So you'd usually say second int by parts. And then you would do your second integration by parts. Now, we label this as fx because we did it in the last question, and we label this as g dash of x. Why? Because this one simplifies when derived, and this one, well, this simplifies more than this one does, because this one actually doesn't. But, okay, so we have fx and f dash of x, and we need a gx, and we have our g dash of x. Fx we're going to call x, the derivative is 1. We have a g dash of x, e to the x, a gx, that means gx is e to the x. Okay, so that formula that I had at the beginning, we're going to use that again. Just this whole lot we're going to use just to answer this little bit here. So sometimes it can be a pain, and probably most times it will be a pain. Okay, so how am I going to arrange this? Okay, that might be good. So integration of x multiplied by e to the x dx. We've already done this before, but I'm just doing it again because you don't just write in this is what it equals. You do this process if you're going to want to get full marks on an exam. Okay, so fx is x, gx is e to the x, minus integral of f dash of x, 1 multiplied by gx, e to the x, 1 times e to the x is e to the x dx. I'm going a bit faster because we just did this, but we still got to do it. So we end up with x e to the x, subtract the derivative, the integral, which is e to the x plus c. We end up with x e to the x minus e to the x minus c. Now, the only reason I didn't use the answer from the main reason I didn't use the answer from the previous example is because I don't want that example. The answer from that example is simplified. We haven't finished the question yet. I don't want to simplify something when the question isn't answered yet. Okay? So we've established that this is an unsimplified version of the integral of this. Therefore, we're going to input this into there. So we're going to rewrite this. The integral. Okay, so the integral of x squared e to the x dx equals x squared e to the x subtract 2 bracket x e to the x minus e to the x minus c bracket. Because I inserted this for here, because that says the integral of x multiplied by e to the x, and that is the integral of x multiplied by e to the x, so I sub that in. Okay? Now that we have that, we can solve. So, we're going to expand this brackets. We're going to leave this as x squared e to the x. We don't need to change that yet. Subtract negative 2 multiplied by x e to the power of x. That's negative 2x e to the power of x. Negative 2 multiplied by negative ex is positive 2ex, because two negatives make positive. And negative 2 multiplied by negative c is positive 2c. Okay. Now, you probably see something similar with these. That's because we have an e to the x. You could say that we have a 2 on these three, but we have an e to the x on these as well, on multiplied to the 2 or an x. So what I'm going to do is factor out the e to the x, and it's going to look something like this. Okay, this is the way I choose to do my simplifying, and I don't want to use another sheet of paper, and I don't want to scribble it in down the bottom, but 2c is correct. You could, if you wanted to, you could say I want v to be equal to 2x, then you would sub in v, but I'm going to leave it as there. It's positive, so I'm happy. And that is it. I hope you learnt something. Thanks for watching.